Hi to everyone, I'm Italo Testa and I'm from the University of Naples Federico II, Italy, and I will present our study on the effects of laboratory activities and visual representation of students' understanding of seasonal changes. The work has been carried out in collaboration with Silvia Galano, who works in my group. So let's give first a little bit of context for the study. Previous research has shown that student misconceptions about seasonal changes are resistant to traditional teaching. Moreover, some authors have pointed out the difficulty of reading and interpreting images as a relevant factor that may influence the persistence of such misconceptions. In our two previous studies, we have shown that laboratory activities can improve students' understanding of the mechanism underlying seasonal changes, and spatially designed images can be more effective than textbook images in helping students overcome typical misconceptions about seasons, such as the distance misconception. In the present study, we aim to fill in the gap and investigate the interaction between the two approaches to teaching seasonal changes. The research questions that guided our study were: to what extent does a laboratory activity improve students' conceptions of seasonal changes when different types of images are used? And the second one is, does the interaction between the laboratory activity and the use of different types of images have a significant effect on students' conceptions of seasonal changes? Let's give some details about the methods that we used. To answer our research question, we adopted a 2-per-3 experimental design. We randomly assigned 337 ninth grade students to laboratory condition and a no-laboratory condition, 170 in the first and 167 in the second. Both groups received instruction under one of the three conditions: textbook images and text, teaching booklets with specially designed images and text, only text with no images. The students had not been taught about seasonal change before the intervention, which took place during the curricular hour for about 6 hours overall. In the laboratory condition, the students first investigated the dependence of the flow of radiation hitting a surface at a fixed distance from the source on the inclination between the normal to the incident surface and the direction of the radiation. Then they investigated how the flow of the radiation varied when the surface is kept orthogonal to the direction of the incident radiation and the distance between the sources and the surface changes. More details are reported in our previous studies, of course. The spatially designed images on the right-hand side featured a circular Earth's orbit and emphasized the constant direction of the Earth axis during the motion. Moreover, the image did not include any arrows to indicate the rotation and revolution of the Earth, as in the usual textbook images, and other information that are not relevant for the phenomenon, as, for instance, the segments that connect the Earth to the Sun, as in these textbook images. Our image also avoided the use of unnecessary text in the image itself, in this case, as for instance the reference to perihelion and aphelion. More details are reported in our previous studies, and we also added a textbook and booklet to minimize the teacher intervention for all of the image conditions. As a research instrument, we use a draw and explain task and a brief questionnaire featuring 2 ordered multiple choice and 6 true-false items. The brief questionnaire was given also as a pretest as a baseline comparison between the 6 groups. True-false items were given 0.5 points for each of the correct answer, while ordered multiple choice items were given 1 point for selecting the partial correct answer and 2 points for choosing the correct answer. Here are some examples for the multiple choice items. As change of season is mainly due to the changing Earth distance, the Earth turning on itself, the changing end of the day, and the changing inclination of the sun rays. And then we have 2 examples of the true-false items. The sun produces more energy during the summer than in winter. The incidence of sun rays on the Earth's surface varies to the year. Students' drawing and explanation were initially categorized using the rubrics reported in our previous study. We use three general categories: unclear, naive, partial correct for both the explanation and the drawings. In this case, we have three examples of students' drawings, for instance. And we also calculated Cohen's kappa to establish interrelated reliability, obtaining satisfactory values for both drawings 0.8 and explanation 0.9. Finally, we also combined the obtained categorical variables from the analysis of drawings and explanation into a single factor by means of multiple correspondence analysis. I cannot go into details now, but we found that the first extracted factor explains 74% of the variance in the data, and positive values of the extracted factor correspond more or less to a correct explanation and a correct drawings, while negative values correspond to an incorrect explanation and a naive drawing. Then, to explore effects of the interaction between the two approaches, laboratory use of image, we performed a two-way ANOVA using as a dependent variable the score in the first factor extracted from the multiple correspondence analysis, and independent variables the laboratory images condition. We did the same using as a dependent variable the questionnaire score in the post-test. Here are some of our results. As expected, the results of the ANOVA on the pre-test questionnaire scores shows no significant difference between the six groups, so the six groups were more or less equivalent in their knowledge about seasons. This is the distribution of the categories of student drawing after the intervention, and you can see here there is a different distribution from the inclination-based, the correct ones, and distance-based drawings. We highlighted the kind of correct drawing. And also this is the distribution of the categories of students' explanations after the intervention, and we see here again differences in the correct and in the distribution of correct answer and naive answers and partial, of course. These are the post-test results for the questionnaire score, and you can see here that all of the group improved their performance, but we studied both the results from the explanation drawings and the questionnaire using a two-way ANOVA. So let's go. When performing the two-way ANOVA on the post-test questionnaire, we found a significant main effect of the laboratory activities and on the interaction between the two conditions, which means that the students in the laboratory condition outperform the students in the non-laboratory condition. We also found that the image condition does not have a significant main effect on the post-test score. However, the simple effect analysis shows that for the textbook images condition and for the no images condition, the difference between the post-test score of the students who performed the laboratory activity and that of the students who did not perform the laboratory activity are statistically significant, with students in the laboratory condition that outperform the students in the no laboratory condition. While the contrary, for the students in innovative image condition, the specially designed images, such difference is not statistically significant. Also, we found here that the students in the no-laboratory condition performed better than the students in the laboratory condition. When performing the two-way ANOVA on the factorial score that combines the responses in the draw and explain task, explanation, and drawings, we found a significant main effect of the laboratory activities, on the type of images, and also of the interaction effect between the two conditions. The simple effect analysis shows that students in the laboratory condition outperform the students in the no laboratory condition in both the textbook images and in the no image condition, respectively, while the difference in the case of the innovative and especially designed images is only slightly significant at 0.05 level. Note, however, that in the laboratory condition, the difference due to the use of images is not statistically significant, while for the students in the laboratory, in the no-laboratory condition here, magenta line, the difference across the groups are statistically significant, due also in this case to a statistically higher score of the students in the specially designed image. So let's go to some concluding remarks for our study. Concerning the first lecture questions, we found that our evidence supports the conclusion that the students in the laboratory condition outperform students in the laboratory condition independently on the type of used image. Textbooks, specially designed images, and no images. These results suggest that the proposed laboratory activity is predominant with respect to the support provided by images in the teaching of seasonal changes. However, concerning the second research question, we found that when students in the no-laboratory condition were taught with specially designed images, their performance did not significantly differ from the performance of the students in laboratory condition. In one case, they also performed better. Moreover, and in this case, so our study, this present study, confirms the results of our previous studies, supporting the usefulness of the specially designed images. Let's go to some implications for our study. First of all, practical activities seems effective to address well-known misconceptions in astronomy, and in special case in the seasonal changes. However, since we know that the laboratory activities are not implemented in usual practice, more effort should be put into implementing it in classroom context, at least as an interactive demonstration or by integrating it with the use of computer-based simulations or other means. Second, specially designed images, and we have found that they can effectively improve students' conception, especially in teaching conditions in which the practical activities cannot be carried out. We have found that when in the laboratory condition we have no effect of the image condition, but this makes the difference in the non-laboratory condition. Overall, we think that this study, the results of our study, can be fruitfully extended to other astronomy phenomena, as moon phases, for which the literature, for instance, suggests a relevant influence of text willingness on students' conceptions. So this is all, and I thank you for your attention, and I hope you find it interesting, and I wait for your questions in the panel session. Thanks very much for